not the log base 10? Is that what you tested? Log of 2? Is that what you tried?
I didn't try anything. I just said I was good.
Why are you shaking your head? You didn't try anything, but you're shaking your head no? That's doesn't make sense. Is it? This number is the natural log of 2. You're going to look me in the eye, and you're going to tell me the derivative of 2 to the x is the 2 to the x function times natural log of 2? It seems like there's a pattern there. That seems like a pattern. Let's try another one. Why don't we try e to the x? F of x equals e to the x. 0, 1, 2, 3. This would be 1. This would be e to the 1. This would be e squared. This would be e cubed. Graph e to the x and tell me the derivative values on the calculator. What is the derivative value of e to the x at 0? Pretty much 1. Okay. What about at 1? 2.718. That number sounds familiar. What about at 2?
7.389.
What about at 3? 20.085.
Yeah.
So according to the Eleanor rule, this thing, because it's an exponential function, it's a number. And see the difference, you guys. A power rule. Everyone look at me right now. Power rule is variable raised to number. Exponential rule is number raised to variable. You see the difference? And don't confuse the two. Power rule is variable raised to number. Exponential rule is number raised to variable. Big difference. Okay? So this is what we were saying here for this one, that the derivative of the 2 to the x would equal natural log of 2 times 2 to the x. So if that holds true for the f of x equals e to the x function, then the derivative would have to equal e to the x times natural log of e. This is 1? Yes.
Yeah.
So, okay, well, let's just check these numbers then. So what that means is that the derivative value would equal the function value at every point. And does it? Well, what is e to the 1? 1 equals 1 makes sense. The e is 2.718 and change. E squared? Check it, it's the same. E cubed? You betcha. So it's holding true. And it does hold true for all exponential functions. The rule, the exponential rule, that we're adding to our toolbox, and we're going to add a flashcard to. Exponential function derivatives. F of x equals a base raised to something, some u. The derivative is going to be that same exact function times the natural log of the base times the derivative of the exponent. Because you can just chain rule it. And I'll show you an example of that in a second. That is the derivative rule for any exponential function. Any of them. And I'll show you what I mean. So let's look at a couple. What is then, you're walking down the street, someone on the bus like, give me your money or tell me what the derivative of 5 to the x is. What do you say? You don't say, here's my, no. You say the derivative is 5 to the x, write it exactly how it is, times natural log of 5 times the derivative of x, which is 1. There's your derivative. You got away this time. What's the derivative of 2 times 5 to the x?
Is that the same as 10 to the x?
No. Because this is multiplication, this is exponents following PEMDAS. You can't multiply before you do that. Good question. This is 2 times 5 to the x, where this is the thing. You put numbers into here and it's 5 times, and then you're just going to double it at the end, which is different than 10 to the x. That thing goes really fast. What's the derivative of 2x to the 4th?
ax.
Yeah. 2 times the derivative of x to the 4th, yes? The constant rule. So what's the derivative of 2 times 5 to the x? 2 times the derivative of 5 to the x, which would be 2 times 5 to the x times natural log of 5 times 1. Good. What's the derivative of 5 to the x squared? The derivative of 5 to the x squared is?
5 to the x squared.
Write the same thing as 5 to the x squared times natural log of the base times the derivative of the exponent. Does that make sense, you guys? What's the derivative of the sine of 5 to the x?
Oh my gosh.
It's fine. Knock, knock, knock.
Cosine of 5.
Don't forget, it's the same rules. Outside in. The derivative of sine of 5 to the x is cosine 5 to the x times 5 to the x times natural log of 5. Where this is the derivative of 5 to the x. This thing here. Does that make sense, you guys? Yes? This is the rule. And again, there's only one other thing that has to do with this, and then we know a log. And it's just looking at a log function, which is just a little changing around. But it's the same thing. It's one more rule, and then you can take the derivative of anything. So then it's just practice. You know what I'm saying? It's memorizing what you need to memorize. Memorizing the rule. So that you don't have to worry about it. You can worry about just doing that and then trying to figure some other stuff out. Does that make sense? So you need to know what the derivative of inverse sine is. You need to know what the derivative of log functions are. You need to know what the derivative of the power rule, chain rule. If you get all that stuff down, then you can just kind of take care of business. You know what I'm saying? Make your flashcards and practice it. Alright? Homework tonight is to do these notes on 3.9. We're pretty much already kind of halfway there. Some proofs in it. With the log one. We'll talk about logs tomorrow. And you'll know every word. Have a good day, everybody.